Well, good morning, good afternoon, good evening, and welcome to everybody to our third series of oil and gas related webinars from Endress Hauser. Today we'll discuss LNG tank gauging with Dandee Bacani. He's an expert in our competence center for LNG storage located in Yamanashi, Japan. He's a member of the strategic industry group for oil and gas within Endress Hauser. And for him, it's already 11 o'clock at night, if you compare it to US time. So thank you very much, Dandee, for doing this so late for us. I think it's going to be a good one. This webinar will last roughly about 45 minutes, 30 minutes presentation, and 15 minutes question and answer. As is common within the Endress Hauser oil and gas and in the oil and gas industry as in general as well, I like to have a small safety moment, and I like to focus on the current COVID-19 situation. It's still not under control globally, but it's going the right direction. Please still keep washing your hands on a regular basis. Keep your distance, 6 feet or 1.8 meters. Wear a mask in public where required. Get vaccinated, please. And when you get the opportunity, and make sure you stay in good mental health as well. This is important for all of us, I think. My name is Rob Vermeulen, and I'm the global responsible person for the development of oil and gas within the Endress Hauser organization, and I reside on our campus in Greenwood, Indiana, USA. But before we start, small introduction of the Endress Hauser organization. As such, you can see it on the slide as well. We're a global company. We employ roughly about 14,500 people in the meantime worldwide. We are financially very healthy, and we have a turnover of around 2.6 billion euros on a global scale. We are very proud of our patents. We have over 8,000 patents, of course, mainly focused on instrumentation itself, because that's our core business. Okay, we are located in Rheinach in Switzerland. That's where we have our headquarters, and that's where I belong to as well. And you see a picture on the right-hand side and how that roughly looks like. It's in Rheinach, close to Basel, in the close to the southern part of Germany, close to the Basel border area. Okay, great. With this, I like to hand over to Dandee. Dandee, are you there?
Yep, thank you, Rob. Good morning, good afternoon to everybody. A quick introduction of myself. Rob did a very brief one. Just to add, I'm also doing marketing manager here as a marketing manager here in Japan, and also a business development manager for LNG globally. 20 years in the field of instrumentation automation, 16 years in Endress Hauser. So my location today is in Endress Hauser level and pressure, Japan. So this is one of the production facility which is dedicated for one of the tank gauging gauge, which is the Servo gauge, and also the multi-point temperature. So here in Yamanashi. Maybe some of you will ask, so where is Yamanashi? So Yamanashi is around 100 kilo away west of Tokyo. And what is maybe one of the easiest way to remember is Mount Fuji, one of the famous site here in Yamanashi. And of course, everybody's welcome to visit our production facility and experience this nice mountain in Yamanashi, Japan. Let's have a quick overview. Safety and challenges in LNG storage tank. So this is very often, of course, a critical topic that we always discuss with regards to LNG storage tank. And of course, with regards to safe operation, these are very often discussed: stratification, rollover, cool down process, and leak detection, product overfill, and product leakage. So I'm sure most of you working on a LNG facilities, your storage tank, this is some of the topic that you are very much interested of. So later we'll give you some overview of those things. How do we handle those, like for example, the stratification, what kind of functionality that we can provide to you, and how can you keep the safe operation of your LNG storage tank. Another topic is, of course, improve operational efficiency. Gauge remote control, real-time notification of stratification, very important thing, level gauge verification. So those are some of the things that we are very much interested with regards to the topic of operational efficiency. Then, of course, also another important thing, precise inventory monitoring. Comparing to other liquid storage, we have some kind of challenges that we might also encounter here with regards to LNG storage, like the effect of the vapor pressure, longer measuring range. This is also a very common question that we encounter because, in an LNG storage tank, we are talking of not only 10 meters tank, but here we are talking maybe 40 or even more, 50 plus height of our storage tank. And of course, availability of data. This is one or another important topic. If you're going to look at the LNG storage tank, normally LNG storage tank can operate up to 20, 25 years, 30 years. So once it is operational, it goes very long before you do any servicing of your storage tank. So availability of data is very critical. This is where a redundant configuration, redundant topic on whether it is on a field instrumentation or on the system side, this is very important. So we will run through our solution, what we can offer to you. And here, let's talk about tank field instrumentation for safe operation and optimum availability. Here is a typical instrumentation in a LNG storage tank. So here you can see just the nozzle or the number of nozzle alone. This is really different from the conventional hydrocarbon or light product storage tank. So here we are talking about the primary and the secondary gauge. So primary gauge, we often recommend to use what we call our servo gauge, and then secondary also you can use a servo gauge. But if you need or if you want to have a diverse technology, different from primary, of course, we can also offer what we call a radar technology. But primary, we always suggest or we recommend to use a servo gauge. Reason behind, later I will show you some of a very unique characteristic or advantages that you can get out of servo gauge. One of them, of course, is the accuracy. Today, accuracy of the servo gauge is the highest with regards to a level measurement. So that is one of the advantage. Then, of course, we talk about the remote display. Imagine a 50 meters tank. Very few people would like to climb in the tank. Of course, they will utilize what we call a remote display at the bottom of the tank. One of the biggest advantage of this remote display is it is a clone of a display on top of your gauge. So your gauge, you have a display, and then of course you have in the bottom. And since this is a clone, you can also do parameterization at the bottom of the tank. Also a quick check when there is an alarm, you can also access it at the bottom of the tank. So that is very unique for this remote display. Then we have what we call the multi-point temperature. This multi-point temperature is linked to the primary and also to the secondary gauge. So the function of this one is, of course, to monitor the temperature at the depth or different depth of your liquid inside the tank, and also the vapor temperature on your vapor phase. So this is the main function of having this multi-point temperature. Then the third gauge that very often in a LNG storage is what we call the level alarm. So here also a very high recommendation using a servo technology. And if a diverse technology is also required, then of course you can have a radar also. So a typical combination you will find in a LNG storage tank, you have the primary servo, or you have the secondary radar, and then you have the level alarm servo. Or it can be also a primary servo, then you have a secondary radar, or you can have a radar as an alarm gauge. So these are things that you will find in your configuration of the instrumentation in a storage tank. The next one is what we call the LTD. This is the level temperature density gauge. So it has a dedicated function in doing the density and a temperature profiling. Why do we need this one? This is used to know whether you have a stratification inside your product in your storage tank. So this is one of the critical instrumentation or an eye in our LNG storage to know whether you have this stratification. Earlier we talked about the stratification and the rollover, so later I will touch on that topic, but just want to let you know now that this LTD gauge is a dedicated gauge for that function. Then of course a remote display. You may need the display, but of course, this is not really something that is in most of the application you will have it. But again, it is available also to have a remote display. The next one is what we call the leak detection, which is a skin point temperature and a combination of what we call a multiplexer. So this skin point temperature is installed outside the inner tank. So you have the inner tank and then you have the outer, then in between you have this multi-point temperature installed at the bottom of your tank. And of course, the multiplexer, it is the one that is collecting all those RTD or element. And then from the multiplexer, it gives you a output going to your system. So depending on the number of element, it corresponds to the number of your multiplexer. So a one multiplexer is can accommodate up to 16 input. So if you have 32 or more than that, we just need to multiply the number of multiplexer. Then the next one is what we call the cool down skin temperature. So very similar to the leak detection. The only difference on this one is the location where the skin point is installed. So with regards to cool down skin temperature, it is installed inside your LNG tank. So it means where the liquid is, it is installed there. So why do we need to have a cool down temperature? This is normally used during the commissioning of the tank before putting our product inside the tank. So you need to bring the temperature of the tank closer to the product. Otherwise, if that is a atmospheric temperature and you introduce your product, you will have a massive amount of vaporization of your product. So you want to avoid that one. Of course, you use a instrumentation for you to know whether the temperature of your tank is closer to your product temperature. Then the next one is what we call a pressure gauge. So pressure gauge is used to monitor the pressure inside the tank, especially if you have monitoring for the BOG. So this is also typically connected to your ESD system. So here you can see a typical instrumentation or very common instrumentation in a storage tank. And as I mentioned earlier, high recommendation from us is of course to use a servo gauge because of some of the advantage that you can get on this technology. And what are those advantages that you can get on the servo technology? In LNG storage tank, manual dipping is something that you cannot do. And of course, if you don't have the way to verify it, how are you going to do it? And that is one of the advantages that you can get out of this technology. A servo gauge can be easily verified whenever it's required, when you need it. You can do a bottom and top reference check of this gauge. And of course, if you use it for your alarm, then you can do a seal-proof testing also anytime it is required. So this is one of the key advantage of this technology. The next one is with regards to stratification. The stratification is a layering of different density inside our tank. So I mentioned LTD is the one as a main gauge that is used for the stratification to do density and temperature profiling. But servo gauge technology can additionally measure density, and you can use this one as a backup of the LTD. For whatever reason, maybe your LTD is not working, then at least you are not going to be blind that you don't have any density measurement inside your tank. So this is another key advantage or unique advantage. Another one is what we call the built-in calibration window. So we have this one as a standard, which is built-in calibration window in a servo gauge. So here you can see in a picture, how does it look like? So on a specific size of displacer, which is the 50 millimeter, you can utilize this a calibration window. But of course, if you have a bigger displacer, then you might need to use a what we call a calibration chamber. So depending, of course, if you require calibration chamber, we can also provide it. But since we have already a built-in calibration window, it also saves cost in adding a calibration chamber. Another one is what we call isolation to process. If you're going to refer, to example, to a BS standard, they also mentioned there that your gauge should be able to isolate during the operation for maybe maintenance. So here, one of the good thing about the servo gauge is you can hoist up your displacer, and then you can isolate by closing the isolation valve. And then of course, you still have your secondary, you have your gauge. Then maybe if that is a primary that is having an issue, then you can remove or isolate your gauge for check or for maintenance work. So those are the unique advantages that you can get out of the servo technology. Now I will give you some of the example of how those instrumentation are installed on top of the tank. This is one example. So here you can see here the primary gauge, which is the servo gauge here. You have here the secondary gauge, which is here. And then you have here the multi-point temperature. On here, on your farther right, you can see another gauge here, which is the servo alarm. And this is one of the old LTD gauge that available in the market, which is installed with a pinch valve. So here, this is what you can see, a typical instrumentation example, how it is installed on a LNG storage tank. Here is another example. So here you can see also the servo gauge here and here. And then here is an example with a calibration chamber. So the previous one, you can see there's no calibration chamber. Then here you have the calibration chamber. So depending on your preference, of course, you can have the calibration chamber. Or if you have a smaller displacer like the 50 millimeter, which we often use in LNG storage tank, you can utilize the calibration window. The isolation valve, and this is the LTD gauge and the pinch valve here. So this is two example, just two references that we have just to show you the example of how is the installation of the gauge. Now let's move inside the tank. So we talk about the cool down and leak detection. So how does it look like? And how is a typical distribution of a skin point temperature and leak detection in our storage tank? So here we have what we call the suspended deck. So here on the suspended deck, depending on the size of the tank, depending also on the number of the points that you wanted to put. So here we have what we call the suspended deck temperature measurement. And of course, you have the membrane wall here. This is still inside the tank. And you have what we call the membrane bottom. So here you can see all those points. Again, depending on the size, it will vary. And of course, it also depends on the preference on the design stage, how many points do you want to put inside. So those that are installed inside the tank is what we call used for cool down, and of course also for process monitoring of temperature when the tank is in operation. Then the next one is what we call the leak detection, which is installed on the outer tank bottom. So here you can see it here. This is spread at the bottom of your tank. So this is what is typical distribution of your skin point for cool down and leak detection. And on top of the tank, we have what we call the multiplexer. So these are the multiplexer. So depending on the number of points, you will multiply the number of the multiplexer also. And this is what we call our TMS01, It is a standard product that we have, which is a multi-point temperature that is installed on top of your tank and then output to the multiplexer, and then from the multiplexer all the way to our system. And how does it look like inside the tank? So this is just an example. So here you can see the RTD element that is now positioning inside or bottom of the tank. And here you have a welding pad. A closer look. So here you can see the welding pad. This is also provided by us, so we can supply this one. Then it will be welded at the bottom of the tank. And then we have the bracket to secure all those elements that is installed in or at the bottom of your tank. So this is an example inside. Then on top of the tank, again, this is the multiplexer, the TM188, and then the junction box, then the RTD input. Now let's move to system architecture example. So depending on your requirements, if you're going to look at the instrumentation on top of the tank, we have those redundancy, we have the primary, the secondary. So we have quite a number of instrumentation. In the system architecture also, we can also provide you a single system, single interface, or we can also provide you a full redundancy. So here I will just show you two example that we also delivered, and of course depending on your requirements we can also provide it and engineer it based on your requirements on the design. So here is an example of what we call a single interface server PC and a client PC. Let me make it bigger so at least you can see a better. So here what we have here is the system cabinet. And then we have here the single interface, a single server PC, and then you have your client PC. So single interface, single server PC, and a client PC. And then from the field, you have a single field input going into your system cabinet. So you have the tank 1, and then you have the tank 2, and then going into your system cabinet. So very cost-effective solution, of course, but if you need to have a full redundancy, of course, this is also something that we can offer. Let's take a closer look. So here you can see the redundant interface, and we also can provide you an option to have a small display here on the interface, and you have the redundant server PC outside your cabinet. This can also be inside the cabinet and then a remote display. So this is also another configuration that we can provide to you. Then also a redundant output to the DCS and a redundant field input to the system. And here you can also see an example of a redundant output out of the field gauge. So it means a full redundancy from the field all the way to your system, to your interface. So for our instrumentation, like for example, the servo gauge, the radar gauge, the multiplexer, also for the LTD, you can have two output, like two Modbus output out of one servo, two Modbus output out from the multiplexer. So you have really a full redundancy from the gauge. What does it mean for you? Of course, availability of data. If one is down, of course, you can still have another information from the other line. So that is one of the big advantage of that. Now let's talk about the functionality of the system. So these are the key functionality that we offer out of our tank management system or LNG management system. First is the inventory management software. It's a fully scalable tank gauging and inventory management solution, of course, for LNG storage site. And the system is designed to fulfill the needs of receiving, peak shaving, and the production terminal or the liquefaction facility. And how does it look like? An example of a HMI here. So here you can see how does it look like. So here, another view. So from here, you can see a more detailed information, a primary gauge, the LTD gauge, and here you can also see an information about the Wabi index, anything to do with energy, and also the total energy. alarm status, and a tank inventory information. So this is one of the example of the visualization HMI that is available in this software inventory software management. Then the next one is what we call the stratification detection software. So stratification is a phenomenon of a stored LNG forming a distinctive cell which is driven by a density differences. So in a layman's terms, you have different layer of your a different density layer inside your tank on your product. And why do you have a stratification? What are the reasons for stratification? So one of the common reasons for stratification is when you do peeling or top peeling, then of course you have flushing inside your tank. And that is also causing those different density of the top layer of your product inside the tank. Another reason, of course, is weathering. So depending on how long you store your product inside the tank, then of course you may also have this effect. This is a normal behavior of our LNG product inside. It is boiling. Then of course you will have this stratification inside your tank. And stratification is very important this is the one of the key process that leads to rollover. So first you will have the stratification, and then you may have this rollover. Rollover is something that you need to avoid. You don't wait to happen. But of course, by having a stratification detection, you will know whether it may lead to rollover. And then when you run the rollover prediction, then you will know when it may happen. But you don't wait for that to happen. Then stratification uses the LTD, the density, and a temperature profile to detect this stratification. A very simple example of the HMI. So here you can see the temperature profile, and then we have here the density profile. Next one is the rollover prediction software. So what is rollover? Rollover is the rapid release of a boil of gas in uncontrolled event, which can have a safety implication. What are those safety implications? So here I will just run a very simple animation so you to understand what does rollover means. So if you have this rollover uncontrolled event, you may have a safety implication related to maybe structural damage if you have a increase of pressure inside your tank, or it can also a loss of product if your BOG management system is not able to handle it. So a simple explanation of a rollover here. So you can see there's a point of time that your upper layer and the lower layer will reach an equalization, and then it will turn, which we call the rollover. So here you can see on a screen, all green is a homogeneous. You don't have any stratification. Then slowly you have a stratification and then equalization. Then you will have the rollover. Then on top here, it will have a what we call a BOG, massive amount of BOG that is released that may cause structural damage or lost product. So LMS software allows the user to visualize the evolution of the temperature, density, and layer thickness of the stratified layer within a tank from an initial condition for temperature, layer depth, and composition, and time to roll over. A very simple visualization again. So here you can see the density value along the liquid height. You can see here the characteristic of your liquid layer. Pressure threshold warning, so you can define this one. And here you can even see here warning risk of venting to the atmosphere, warning vapor pressure exceeded the tank design pressure. So here, as I mentioned earlier, if the expected or the prediction out of the rollover that may exceed the pressure, then of course you will have also those information on your system. And of course, the time to roll over. So here, when it runs, it says here you have 6 days plus 15 hours for the rollover to happen. Again, we don't wait for it to happen. It is a tool for us to predict. And then once it is predicted, you need to do a measure. What are those measures? of course, you need to make your product homogeneous inside your tank. How are you going to do that? It can be you transfer it to another tank, you circulate it, or the system also allows you to know what is the density inside your tank. And then if you're able to do a bottom loading or top loading, so at least when you load your product, it will make the product inside homogeneous. So those are the things how you can avoid those or what the measure that you need to do to make your liquid homogeneous. Then the next one is the temperature monitoring, cool down, and leak detection software. So here, this is again another simple HMI for temperature monitoring as an example here. So here you can see those small dots. I hope you can see it. Those small dark dots, those are the location of our element. So if you're going to take a closer look here, if you click on those points, then you can see a more detailed information of that specific element that is installed inside your tank. So the location, the height, and also the measured temperature. So this is very critical for you to easily monitor whether there is some abnormalities inside your storage tank. Then another one is you can configure also a alarm threshold. So here you can see that where is the location of your different points, and then you can allocate a alarm on your system. So that is the functionalities that you can get out of the system. Now I'm going to show you a short video of an example of the system cabinet. Oops, sorry. I don't know what is. Sorry for that. It's not playing, I think.
It seems like it, Cindy.
Oh, you can see it?
No, it's not. It's not running. No, we can't see it.
Mm-hmm. I'm not sure what is wrong now. Okay.
Yeah, it's running now.
Okay. Sorry for that. So here an example of a system cabinet. This is actually available here in Yamanashi. So here you can have the maintenance display, the keyboard, the redundant server PC, the AC-DC converter, the circuit protection, and the earth leakage breaker. So this is just an example of the system cabinet we have here. And then on the operator side, so this is an example of how it looks like. So a typical HMI. Tank overview, LTD gauge detailed screen, and of course the single profile viewer that you can see on your screen. Of course, this is just a very short glimpse of the system. If you are interested to see the whole functionality of the system, we can set up and we can demonstrate it to you. We have a running system here in Yamanashi. And just to summarize, this is how the system looks like. So from the field instrumentation on top of our tank to the interface, a redundant interface to the system, this is what we can provide to you as a complete LNG tank gauging system. To show you some application references, so here we have in Australia, this is for 2 times 160 cubic meter LNG tank. Not only the LNG tank, but of course they also have the CT tank, C4, and the condensate and the LPG. So here you can see what are the instrumentation that is supplied. And this is running since 2017. And here another one in Kuwait. This is quite a big project. This is 8 LNG tank. Here we supply 16 servo gauge, 8 radar, 16 multipoint, 8 LTD, and 2 system cabinet with a software, with a rollover, and also a stratification. This is another one in Russia. So also a big size LNG tank with the 8 servo gauge, NMT, LTD, and also a 2 system cabinet. Another one in India just recently in 2019. So here you can see also a very good size of a storage tank with a 4 servo gauge, radar, multi-point, 2 LTD, 1 system cabinet, and a complete management system plus rollover prediction system. That's all from my side. Rob?
Yes. Well, it was a great story, man. Thank you very much. And we have a lot of questions as well. So I will start doing those questions later on. First of all, I like to point you out that there is a handout of a lot of these slides that you can download at your convenience on the right-hand side of the GoToWebinar dashboard as well. So please, if you are interested, please do so. I also have a question. Because this was the last webinar that we're giving with regard focusing on oil and gas related themes, and third series, and we were wondering if we can get some feedback from the audience we've had whether we should continue or not. So I will launch a poll. And it would be great if you could answer that on your screen as well. That would be fantastic. You see the question? So we're collecting the votes now. A bunch of you guys have already voted. So I'm closing the poll now. And this is the answers. So a lot of people like it, apparently. So that's a good deal. Thank you very much for your confidence and the liking of our seminars and the way we conduct them. Really, really appreciate it. So we'll have a look, and we'll if you have new topics that you would like to be sharing, or topics you like to hear more about, please let us know. You can always send us an email to rob.vermeulen@endress.com or dandee.bacani@endress.com. It's our first name, last name, with a dot in between @endress.com. So that's very easy in that regard as well. So let me stop this now, the poll, and let me get to the questions, because we have a lot of questions, Dandee.
Okay.
There we go. There are some questions about how a multiplexer will communicate to the system, because you see a lot of wires coming from those temperature multiplexers, I think. And how do they communicate?
Yeah, we have the industry standard Modbus output out of that multiplexer. So you can have a single output, or you can also have a 2 Modbus output, so you can fulfill this redundant output out of the multiplexer.
Yeah, so it's normally 3 wires, no?
It's a 2-wire Modbus communication. So that is all of our communication output that we use for the instrumentation for our LNG solution. We use the Modbus output.
Okay.
Yeah.
But don't forget the ground, by the way. RX,
yeah.
EX, and ground. So 3 wires. Yeah. Good. Then we have another question. Can we use all field instrumentation for other organic products like benzene? Now, we focused this time on LNG, and we have another expert on the line as well. His name is Volker Schulz, and he is normally the expert that takes care of other products than LNG. So, Volker, I'd like to give you that question. Can you elaborate a little bit on that?
Yes, basically the devices, the Servo,
Volker, we can hardly hear you.
Yeah, now you should be able to hear me. So yes, and you can also see me. So
yes,
those devices, the servo and the radars, will be able to talk when we consider the chemical resistance to this product. And sometimes we select a servo, or sometimes we select the radar as a preferred solution, because at the end we need to achieve the accuracy independent of the gas influences of that product.
Yeah.
So the
maybe
answer is yes, a lot, yes, but you have to take care of the chemical composition and also the materials that are coming in contact with the product as well. And maybe even some of the components that you use in an LNG configuration, you do not use on benzene or other let's go liquids, more liquid-like products as such as well.
Yeah, I would not use in this case the LTD gauge, because the servo would be enough to create a profile for you to show that you have a separation or layering of products inside the tank with a density profile of 50 density points. You will see that if you have to mix the product again before you sell it.
Yep. Maybe I can add on that one, since you mentioned the LTD Volker. There's a specific actually usage of the LTD, especially that is the density profile and the temperature used for the rollover prediction. So normally you will find this one in the LNG storage atmospheric tank, and also for the LPG, which is also the atmospheric tanks. But there's also a difference on this one, because on the LPG, of course, you don't expect any rollover. So you can also skip the usage of LTD here. And then, of course, the servo gauge is more than enough to handle those applications.
Yeah. Okay, and then the next question, it's from Subar. Can you, Dandee, it's for Dandee also, do you have any API standards that you can refer to with regards to LNG tanks manufacturing or LNG instrumentation?
Yeah, there are a few standards I would say that you can refer to. One of them is the EN1473. The EN1473 is mostly related to the installation equipment for the LNG on onshore. Then there's also the API 620, if I remember correctly. So this is the design and construction of the large storage, and then you have also the GIGNL. So those are the common standard that you can find in LNG storage. Then of course you also have the ISO 18132. So those you can refer to those standard.
Yeah, especially the GIGNL, the GIGNL, is very, very useful and very practical with regards to the specification or utilization of those tanks and how to construct them as well. They give good input, definitely. Then we have a question on leak detection. I think I can give it to both Volker and Dandee. Just determine yourself which one wants to answer. Can we use leak detection for an underground tank? Dandee?
For an underground tank, you mean the skin point temperature?
Yes.
On the underground tank, that is a good question. To be honest with you, we haven't installed anything on the underground tank. I can double check, but based on our experience, I think we don't have the installation on underground tank.
No, I only know them also from above ground tanks only. But it's also what you want to measure as well. If it's for LNG, it probably will work. I can see that work. But
yeah,
if you
I don't see
measure
any problem.
Yeah, if it's for other liquids, then it's a different story, I think. Then it's probably not. It should not be based on temperature difference, but it should be based on property difference, I guess. No? Then a similar question as well. Can we use those multi-point temperature in jacketed tanks?
Jacketed tank, normally not, but to be honest, also I don't have any experience that we installed it in a jacketed tank.
Nope. normally not used. It should be working, but I don't think it's common. Let's put
Not
it
a
that way.
practical solution.
Yeah, not very practical. And then we have a very difficult question, a long question, I think. What is SIL certification? We had some webinars in the past just focusing on SIL. These were normally 45 minutes long. So Volker, do you want to give it a go in 5 seconds?
In 5 seconds, when I read the question, the SIL certification of our devices is SIL 2, in redundant mode SIL 3, and it has a safe failure fraction of 98%, if that answers the question. Each of the tank gauging devices, not the LTD.
Yeah, there's no SIL approval on the LTD. Yeah, maybe just to add on that one, if you remember, how does it look like? We have three gauges. We have the primary, secondary, and the independent alarm. We can also provide you an output out of the primary and secondary. And then if you want to have SIL 3, of course, you can utilize also having a 2 gauges having a SIL 3 approval.
Yeah, that ties great into the question from Eric as well. Why do you have a separate level gauge for alarming? Why don't you use the 2 primary gauges to alarm? Which is, I think, a very valid question.
Volker wanted to answer it. Go ahead.
Yes. In the earlier days, we had not devices designed definitely for safety application like we use it today, where a device is SIL 2 designed and be usable for level and measurement. So we did a voting 2 out of 3. That was a common practice. And it was always a requirement to have a primary and a secondary device for redundancy of the level measurement. So in case something fails, that we have a backup of this one. And so common practice wants to have another device for overfill prevention. 3.
Yeah. If also you're going to refer to the standard example, the EN1473, it is also mentioned that you need to have an independent alarm that is connected to the EST. And of course, also you can connect or have an output from the primary and secondary.
Yeah, and preferably it should be a different measurement technology as such as well.
Yeah, that is where you
avoid systemic errors of the measurement. If you have 2 radars and both work the same way on the signal itself coming from the service, then it's better to have a radar and a servo, so you have 2 different technologies, so you don't have this systemic issues.
Yeah, this is a requirement.
Next question. What is the recommended size of? Excuse me? What is the recommended size for the stilling well for a servo and a radar level transmitter?
Yep. So for servo gauge is always a 6-inch steering well. Then also for a radar gauge.
Did you hear my question?
Yeah. Can you hear me?
Yes, we hear you.
Perfect.
Rob? Yeah, so it's a very common, we use a 6-inch steering well. For LTD, also a 6-inch. For multi-point temperature, it's often you will find smaller. For the skin point temperature, it will be a bigger size. It can be 10 or 12, and then it will be reduced also. So those are the typical size of the steering well.
I think you need to switch off your camera. Hello?
Yep, can you hear me?
Now I can hear you again, yes.
Okay.
So,
go ahead,
next
Rob.
question. Which elements of the system could we be installing within an existing tank, so without emptying the tank? So they want to install instrumentation without taking the tank offline.
Well, it depends on availability of your steering well and isolation. So of course, if you have the existing stealing well and then you're able to isolate and like for example, a servo gauge is one of the advantages. Of course, you can install it and then open the isolation bulb and then you make the gauge work. And with regards to the multi-point temperature, I would say, again, depending on what is the current situation in your tank, if you have a design on a stealing well that is closed, then of course you can insert the multi-point. But if that is open, then you need to put the tank out of service.
Yeah, that's not so easy, Erik. But some can be done, and like Dandee is saying, installation of the different connection points is very important in that respect as well.
Yeah.
So we have another question from Sarab. How can you confirm that the servo float has reached its calibration chamber in a high pressure storage tank?
Well, normally you have this a glass window that you can see, and of course the gauge also can tell you. So visually you can see it.
You can actually physically see it. There is a thick glass window up there. You can see actually the float being retracted to its calibration status.
Yeah,
so that's
great. One of the advantage that you can utilize since it is standard, it is built in, so it's visually you can see it.
Yes. We also made a mistake, Dandee. We did not explain what an LTD measurement is. Paul pointed that to us, and he's right. Okay. Can you explain a little bit what an LTD is?
Well, the LTD, it's a single device that can provide you a level, temperature, and density measurement. The density measurement is you have this oscillation in the probe. So it means changes on the oscillation, it equate to a specific density. And then the temperature is measured having a temperature element. And then the level measurement is measured using a resistance. So it means when the probe reaches the surface of the liquid, when the probe is inside the liquid, there's a specific resistance. When the probe is outside the liquid on the vapor, there's a specific resistance. Then the difference, of course, it can identify where is the liquid level. So there is a chain inside this LTD, and then it hoists up depending on the command. Like, for example, you did a command of profiling, then it will start doing the profiling. It goes down, it do a level calibration, then it start doing the profiling. Depending on what is the defined interval for the profiling, it can be 500 millimeter, or very often it is from 500 to 1 meter interval of the density profile. So I hope I explain it in a brief.
And now I'm going to the last question. There are some more questions. We'll come to those as well. We will contact you separately, no issue. We have an email address, so we will come back to that as well. But this is a very interesting question because it's a very practical question as well. It's also from Sarab. Our radar level alarms are not working due to the rough surface of the stilling well. Mm-hmm. Can you give us some advice what to do?
You need to make sure that the stilling well is clean and not rough.
Yes. I think
that is one of the critical consideration that we need to take into consideration in using the radar gauge. So that is also one of the, I would say, if you're going to consider using a radar gauge on old tanks, old stilling well, this is something that we need to be very careful. If that is a new installation, of course, you can make a stilling well according to the requirements of your radar gauge.
Yes, that's a rough situation, definitely. And from my past, I can also recall that we have been advising some servo gauges for those stilling wells because they last better, or they perform better in these crappy, let's put it that way, stilling wells in certain applications than a radar, because radar, they develop electromagnetic signals, that are being influenced by the roughness of the stilling well and welding seams and holes in the stilling wells and so on and so on. So the creation or the development of those stilling wells is very, very critical for a good performance of a radar in a stilling well. And often these requirements are a lot less when you go to a servo cage. It's one of the advantages of a servo cage. Huh?
Yeah.
But we need to have a look at that, and then but we come back to you with regards to that as well. Last question. Dandy, you were talking about energy calculations for LNG, because for LNG you don't want to just know the level in the tanks. You also want to know how much energy is left into the tanks as well, because LNG you trade not just in quantity but also in heating value. So in order to calculate the energy content, can you connect a secondary device that determines the heating value of the LNG in the tank and display that on your system?
Okay, heating value or composition?
No, heating value.
Okay. Heating value, well, it depends on what will be the input that we can that is coming out on that device. So
I think
like for example,
talked about Wobby, no?
Yeah, but if I understood correctly the question, it is a separate instrumentation or coming from information. It can be from DCS feed to the system, or
yeah, I think what they use sometimes is either a Raman spectrometer in order to determine the amount of C and H's in the LNG composition, or a gas chromatograph. No?
Yeah, well, normally in our system, of course, we can calculate the energy, and what are the information that is required for us to calculate the energy is one of them is of course the composition. The composition can be coming or feed from a external device. It can be from a I can mention the Raman analyzer, or it can be also feed from the DCS. So if there's a field device connected to the DCS or information from the DCS, it can also be received from our system, and then we can also do the take that information for the energy calculation. And also in our system, also we are able to do what we call a automatic composition, utilizing the use of the LTD. So this is also another function in our system that is available.
Perfect. Well, thank you very much. Sorry that we took a little bit more time, but we have a lot more questions. We can spend another half an hour at least just answering questions, but the time is up. So thank you very much for your contributions. Thank you very much for your voting. We will come back, so be on the lookout for more presentations that are oil and gas related that we will come out for. We'll take a short break in time, so we can prepare those series and get the right topics in place, and then we will continue. So we will do that. So thank you very much. Thank you very much, Dandy, for your presentation. Thank you very much, Volker, for your contribution as well. And we thank you, audience, for staying with us, and hope it was of interest for you as well. And with this, I end the webinar. Thank you very much.
Thank you very much.